Today, let's talk about the fundamental theorem of calculus, part 1. If the function f is continuous on a closed interval from a to b, then to find the derivative of the integral from a to x of t dt, we can simply replace the variable t in the integrand by the upper limit x, so we get fx. But before applying this formula, we need to make sure the lower limit is a constant and the upper limit is the variable x. So let's look at our first example. Let's find the derivative of the integral from 1 to x t cubed dt. We know the integrand is t cubed. So to find the derivative, we can simply replace t by x. So we get x cubed. Now let's see next one. If we want to find the derivative of the integral from x to 0, cosine t squared dt. For this one, we cannot directly apply the formula because the lower limit is the variable x. But we can swap the upper limit and the lower limit. So we get the derivative of the integral from 0 to x. But you need to put negative here. So get cosine t squared dt. Now we can apply. So get negative, replace t by x. So we get cosine x squared. Now let's see how to find the derivative of this one. So dx and the integral from 0 to 10 x. The integrand is t squared plus 1 dt. Can we simply replace t by 10x? So we get 10x squared plus 1. The answer is no. In order to find the correct answer, we need a new formula. So the formula is derivative of the integral from a to a function hx of t dt. First, we need to replace t by the upper limit, so we get hx. And then we need to multiply the derivative of the upper limit, which is h prime x. It is actually simple to prove, so let's see. We let capital Fx equals integral from a to x of t dt. Then we replace x by hx, so we get a of hx equals integral from a to hx and of t dt. So the target d dx integral from a to hx of t dt. It is the derivative of the composite of functions of hx. Then at this point, we can use a chain rule. So we get the derivative of the outer function, so prime at hx, times the derivative of the inner function h prime x. And we know the derivative of outer function capital F, x equals little f. So we get little f at hx, and then times h prime. So we get the same answer. Now we can apply this new formula to find this one. So the derivative from 0 to 10 x t squared plus 1 dt. First, we replace t by the upper limit 10x. So we get 10 x squared plus 1. And then multiply the derivative upper limit. So 10x derivative. We know 10 squared plus 1 equals secant x squared. And the derivative 10 also equals secant squared. So finally, we get secant x to the 4. Finally, let's look at our last example. So we want to see how to find the derivative of this integral. So we just x squared to sin x square root of t cubed plus 1 dt. You know, the new formula cannot be applied to this one because the lower limit and the upper limit are both functions of x. But we can use a property of a definite integral. So given a definite integral, say a to b of t dt, one way to evaluate it is to break up the interval ab to two parts, say a to c and then c to b. Then the given one x equals a to c of t dt plus c to b of t dt. Now let's use this property to find the derivative. So we get derivative with respect to x. So from x squared, we integrate to 0. So square root of t cubed plus 1 dt plus from 0 to the upper limit, so sin x, and then again square root t cubed plus 1 dt. Now we can take the derivative for each term. So we get derivative for the first one. At the same time, we swap the upper limit and the lower limit. So 0 to x squared, but we need to put negative here. So square root t squared cubed plus 1 dt plus derivative. So plus the derivative, the second one. So d dx integral 0 sin x square root t cubed plus 1 dt. Now we can apply the new formula. So we can negative replace t by x squared. So we get x squared and then cube plus 1 times the derivative of the upper limit. So x squared derivative. For the second term, we replace t by the upper limit sin x. So we get sin x cubed plus 1 and then times the derivative of sin x. So finally we get, so x squared, the root of x squared equals 2x, so negative 2x times 2 times 3, 6, so we get x to the 6 plus 1 plus square root of sin x cubed plus 1. The root of sin equals cosine x. That is the final answer. Thank you for watching.